Hey, this is David Breen with BreenDesign.com, and today we're going to go over mParticles. Now, mParticles are physics-based particles. Now, if you hit 6 on your keyboard, you'll get your particle view, and this is where all the magic happens. Now, mParticles are basically what the developers did was they took basically what you can already do with normal particles. You know, you can add forces to them like gravity, and you can control things externally like that. But mParticles takes gravity into account already as far as colliding with objects, and it's basically a whole new system. And it's mixed in with everything else, because there are times where you don't need particles to follow physics, so necessarily. So as soon as you create an mParticle flow, you drag it in here, you get a grid, a 5x5 grid of cubes, and you hit play, and they all fall down and they all collide. And this looks like something that you could set up with Mass Effects. If you're familiar with Mass Effects, it's a physics-based animation system, so you could have created all of these blocks here and set them all up like this, made them all dynamic rigid bodies, which means physics takes over and they do whatever, which means they'd all fall and they'd all hit each other. Now, if you made this simulation here with Mass Effects, it would just be a simulation. You would not be able to scrub through the timeline like this. And you would have to bake the simulation in order for it to be, you know, a part of the scene permanently. And once you bake it, that's it. It makes keyframes and you can't change it or alter it. By making this Mass Effects physics system built into particles, it makes it so that you have complete control over anything that this does. Like if you have a wall in the way, and I can demonstrate by creating a box, and we'll put a little box right here, and we'll throw this box underneath it, like right here, and then you create an MP collision, put that in there. You want to add a deflector, and it has to be a deflector. So I believe what we have to do is on this block here, this box I made, we have to add a particle, not that, that's for something else that we're going to do later. You want to add a p-flow collision shape to it, and then click activate. Also, smooth surface is a good thing to click. And then you can add, and there it is. So you have to activate it first with this modifier, this p-flow collision shape. Activate it, then it's selectable as a deflector. So there you go. And if you were to just add right here, if you go to create and you go to space warps, deflectors right here, you can add deflectors, and that will have that built in, and it'll already recognize it as a deflector. But if you want an actual object to be a deflector, you have to go through that process. So now if we hit play, whoopsie daisy, this MP collision needs to be below the world. Now you see they all land on this block. Now if this was a Mass Effect simulation, that's it, you're done. There's nothing you can change. But since this is particles, you can grab this block here and you can move it, and in real time it will show you what the results would have been at this point in time. Please excuse the obnoxious bass coming from downstairs. Okay, it stopped. So yeah, that's really sweet. You can actually interactively move the objects around in your scene to see how the particles will react. Alright, now there's something that you can do. Let's just take that out. As you can see, if you push play, it looks smooth, but if you try to scrub through the timeline, it's a little jumpy. And now for this, what we want is, there's cache disk, which is new, and there's also cache. So the cache operator records the particle states for faster playback, so you can cache it up here. You just grab the cache, put it here. Whoops, you don't want to replace it. Put it below. And this is the equivalent of baking your simulation, but you're not actually baking it. You're just creating a file, a cached file of it, so that you can play a simulation back that you're happy with by scrubbing on the timeline to get the details. So active segment, update always, sampling every frame, and then what we want to do, I'm not too familiar with this, but it's pretty self-explanatory. I believe if we just do, I don't think we have to check anything. I think you just click update and it plays through. And now, yep, now if you move it around, it runs great. And so the new cache disk records the particle states to disk for faster feedback. Some particle properties can be excluded from caching. Oh, okay, so that's a more advanced. That's pretty cool. You can cache certain particles. Really? Some particle properties. Okay, so particle properties. So yeah, you can see. Well, you probably don't understand what that means if you're watching this tutorial and actually learning something. But more options is always good, and that's what Particles is all about, and mParticles, and all these crazy icons we have here in Max 2014. It's a lot to learn. It's very complicated. On top of that, we have something called the data operator, and you go into edit data flow and look at this. We've got another system full of icons within a system full of icons. It just keeps going, folks. And this data operator is basically the nuts and bolts of the program. It allows you to look under the hood and see how all of these different functions here were created. You could actually recreate all of these functions with this data operator. That's what it's there for, to create your own custom ones that don't already exist, or to improve on them, make them better. And there's a bunch of different data presets. There's just a few here. When I watch tutorials from the Autodesk folks, this list is just packed. And so tube follow, surface spread, suction hole, reduce cached lifespan, particle per vertex is really cool. That will take a mesh that you have and it will turn every vertex into a particle, or it will place a particle at every vertex. Yeah, it spawns particles to match the number of vertices. So it's a very exact way of doing something. And if you were to open this here, yeah, so they don't allow you to go in and look at the code. You can turn that off and then add which options you want here for the user. And so the only option they have for this is just to pick an object. So anyway, that's the basics of that. And I think what I want to show you now is, where are we at? We're at 8 minutes. Alright, let's bring in an mParticle flow. I'm going to pause this for a second. There's a helicopter going by. Alright, birth grid. That creates a grid with that you set within this grid the area. It's like a volumetric way of looking at particles. You set the volume area, and then you set what happens with those particles within that volume. And you can even place, let's say, a head, a character's head, or whatever object within the area, and then you can have the particles disperse along the geometry, the typology of your character. And we're going to actually do that. There's all these other ones here, but we don't need any of that right now. So let's go to create, and let's see, what do we want to destroy? Let's do we want something a little more complex. We want the torus knot. Torus knot's pretty popular. So we'll drag that in, and now our goal is to get this torus knot to fall apart. First we'll make it melt, and then we'll have it actually break. And if you wanted to break something before this mParticle system that just came out, it's not perfect yet, and it takes some tweaking, and I'm sure they're on the right path with their thinking of this, how this is going to work. But what the mParticles will do is it will break your object and by the vertices. So wherever your vertices are on your object, according to your typology, that's how it will break the object. And before this, you had to use a script to pre-break an object, and then you would simulate all of those pieces that were breaking, and they'd all fall apart according to forces like bombs or gravity or whatever. But with this new particle system, your object will fall apart or conform to the particles within it. So you can think of the particles as the spirit of your object, and your mesh is the body. And you can literally get the particles to do anything you want, and your mesh will follow it. So this has infinite possibilities. This is really cool. But here's just the basics on how you do this. We want to create two of these. One of these torus knots will be one for the particle system to obey, and the other one will be the actual torus knot that we will have skinned to the particles that are following the other one, and then have it obey the particles. So you got to have two of them, and that fact alone shows you that this system is still kind of in the works. It's still beta. There's some steps you have to take, extra steps you have to take that that shouldn't be necessary if this was a complete system, but it's not. So we have to go up to edit, and we have to clone a copy, and we'll call this one the particle knot, and create a new layer, particle knot, and we'll just put him in there. And then this other torus knot here, select him, and we'll rename this guy destruction knot. Alright, so we have our two. Ding. Okay, so let's hide the destruction knot for now. That's the one that we will skin to this one that we're working with. So I'll color this one a little different than the other one so we can tell them apart. And now what we do is we want to put this within the volume, not of this. You would think this is the volume, but this is the this cube represents the actual physics. See, if you click on this thing and you go to modify, it's called MP World. So it has the gravity and has all the parameters set for the physics engine that these particles will obey. Now you can't, this icon here is a separate icon down here. This is just a general particle flow icon. The grid that we want is actually not visible right now. It's being taken up by these cubes. So their system needs a little tweaking. I think this one here should not be a cube. That's confusing. It should be something else that represents gravity. It looks like gravity. And then you should be able to see or select by hand the one up here, but you can't. So you got to go up here and select by name, and it's the birth grid. So we select that. See, we've got it, but where's it at? Now we got it right here in our particle view. We go to the birth grid, and we got to scroll all the way down to icon size, and that's what this is. It's the icon, and we want to bring the length out and the width and the height. So bring it up about that much, And let's hide the display. You could also do this. See what I just did? Select by name. You can also click on these icons to hide them, so you can hide all the cubes. And now we've got this wireframe here. So this is our grid area. So let's unhide our other torus so we can move them together. And let's move it into the grid. Shrink it down. And you know, you should be using your 4 views for something like this, but you know, then you gotta close all your menus, blah blah blah. So that's good enough. So now we got all these cubes within here. Let's just go to MP shape, actually shape itself, and bring the size down, something more manageable like that. Now the reason why you want cubes and not spheres to attach to your object when it falls and follows these particles is because you want it to stop. You want the pieces to fall and stop, and with a cube they'll stop. If you have spheres, your object will start to roll outwards and look like it's melting, which is also really cool looking. Alright, so we want these particles to go inside of this knot. So we go to birth grid and we go down, restrict by mesh volume. So click that, and then interactive update is always nice, and then click none and click on your torus knot. First we gotta hide the destruction one, and there you go. Now if we hide our particle knot, there's the particles following the knot mesh. That's really cool. The possibilities are through the roof. Alright. Now we can go back to shape. You can make them bigger. And if you want more, let's see, grid size. So you can make a bunch, go back to shape, bring them down. So we got a bunch of particles, and they're going to bring down this torus knot. Alright, so now we'll unhide the destruction one. We want this destruction guy. Well, first of all, let me play this for you to show you what it looks like. They all fall to the ground. Okay, so we grab the destruction knot, and what we have to do is we have to apply a modifier to this that tells it to follow these particles. So we go up to the modifier list and we go down to, well, you know what, don't confuse yourself, just type PAR for particles, and it's right there, particle skinner. Particle skinner. What a feature, huh? Alright, so we've told this object to skin to some kind of particles, so we got to go add particle flow systems, add, and what do we do? This one here? This is our particle flow system, this little orange thing at the bottom. These are just extra options within it that they added. So once again, this is the volume of the particles. This is the MP world physics object icon, and this icon here is for the actual source of the particle flow itself. So that is what you would add on the skinner. So now you have to click activate skinning, and you have to deactivate it, activate it again every time you change a parameter. But I think we're going to be good. So we click activate skinning and push play. There it is. Falls apart. Now let's hide these cubes so we just get, hey now. And you can see it just falls to. So that's one way to deform your object. And you would think if you wanted to actually tear this apart instead of having it flop to the floor like a hose or something, You would think you'd have to go into here and add some kind of break apart or whatever, but it's actually built right into the parameters of your Skinner system. And it's kind of confusing within this system here because the only checkbox you see is remove uncontrolled. It's like, huh? And right above that it says rip surface apart. There should be a checkbox next to rip surface apart, but it's right there. So you click that and you want offset, and offset allows you to choose where it breaks according to its relation to the particles around it. I believe that's what it is. Don't quote me on that. I guess I just quoted myself. Okay. So then we hit play. That didn't work. Aha. There we go. Remember, you gotta activate skinning. You gotta check it on, check it off. And it breaks into a bunch of little pieces. Now, because the mesh itself is hollow, it keeps it hollow. Usually if you break it with Rayfire or one of those other Fracture, Voronoi, one of those other scripts, it creates volume inside of your object, so it's no longer a holograph or a hologram. It's not a hologram, just hollow. But this doesn't, so you have to create like a shell modifier or do something in order to get something inside of it. There's other modifiers you can play with, but yeah, this is really neat. Now let's add a wind force to this, so when it falls, let's see, well, you know what, this is probably good length for the tutorial. You guys get the idea, you know how to add stuff. But yeah, if you add a wind force, alright, let's just do it real quick. Go over here to space warps and you add a wind, and we'll have it blow over and break. So we'll add a wind, rotate it like that, and then we go into here and we want an MP force. Put that there, I believe. Add. Alright, and then if we play, yeah, the wind blows it, and it continues to blow the pieces. And then we could turn it up even more. Play. So, you know, for a quick effect of something breaking, and if you had a shell on this and they had some volume to it, that's a real easy way to break things up and to be able to fly the pieces around and do things with them. That you could do that with an MP group as well. If you go all the way over here, MP group, like you can break all the pieces up and then you can make each piece a particle. But you know, there's a lot of different ways to accomplish the same thing in this program. It all depends on what you're doing, and that's the basics of that.